Welcome to two examples of identifying a horizontal stretch or horizontal compression. G of x is a transformation of f of x, where g of x equals a times f of bx. We want to determine the value of a and the value of b. To do this, it's going to be helpful to analyze the coordinates of corresponding points. So let's find the coordinates of these 3 points for f of x, and then these 3 points for g of x. So for f of x, this point here has coordinates -2, -4. This point has coordinates 1, 6, and this point has coordinates 3, -6. And then for g of x, we would have -4, -4, 2, 6, and 6, -6. Now by analyzing these points, notice how the y-coordinates are the same, which means we do not have a vertical stretch or vertical compression, but the x-coordinates have changed, which means that we have a horizontal stretch or compression. So we should be able to see that from f of x to g of x, f of x has been stretched horizontally to form g of x. So looking at our equation, g of x equals a times f of bx, because we don't have a vertical stretch or compression, a would be 1, so our goal here is to find the value of b, which affects the horizontal stretch or compression. So for a quick review, again, it doesn't apply in this case, but if we have y equals a times f of x, where a is greater than 1, we have a vertical stretch, which we see here by y equals 2 times f of x. And if a is between 0 and 1, we have a vertical compression, which we see here by y equals 0.5 times f of x. But again, in our case, because we have a horizontal stretch, we're concerned about finding the value of b. So in this form, if b is greater than 1, we actually have a horizontal compression, which we see here by y equals f of 2x. And if b is between 0 and 1, we have a horizontal stretch, which is our case, which we see by y equals f of 0.5x. And this should make sense because notice how for the same function values of y equals f of x, for y equals f of 0.5x, it would take larger x values to have the same y values as f of x. For example, here, notice how if x was 8, 0.5 times 8 would be 4. When x is 8, this would be f of 4, the same as the function value when x is 4 for the basic parent function. But to find the value of b is a little trickier than determining the value of a. If we start with the parent function, we would multiply each x-coordinate by 1 over b to determine the x-coordinates of the horizontally stretched or compressed function. So if we can determine what we multiply by to find the corresponding x-coordinates, we would set that value equal to 1 over b and then solve for b. So going back to our example, if we take a look at the corresponding x values, notice how -2 times 2 is equal to -4, 1 times 2 is equal to 2, and 3 times 2 is equal to 6. That does not mean b equals 2. b is actually equal to the reciprocal of 2, or 1/2. So we could set up an equation as 1 divided by b equals 2 and solve for b, but it will be the reciprocal of 2, or 1/2. Let's go ahead and just show that. I'll put this over 1. I'll go ahead and cross multiply. 2 times b is 2b, must equal 1 times 1. So 2b equals 1, divide both sides by 2, b equals 1/2. Which means g of x is equal to, again, a is 1 because we do not have a vertical stretch or compression, so we just have f of 1/2 x. So a is equal to 1 and b is equal to 1/2. Let's take a look at a second example. Again, let's find the coordinates of key points on each graph. So we'll find the coordinates here, here, and here on f of x. So we have -6, 7, 0, -4, and 3, 3. And then for g of x, let's find the coordinates here, here, and here. So we have -1, 3, 0, -4, and 2, 7. Now this one's a little trickier because notice how the high point on f of x is to the left and the high point on g of x is to the right, which means this point here corresponds to this point, and this point here corresponds to this point. So once again, notice how the corresponding points have the same y-coordinates, which means there is not a vertical stretch or compression, but the x-coordinates have changed. They've also been reflected across the vertical axis or the y-axis, which means f of x has been compressed horizontally and also reflected across the y-axis. Now let's compare corresponding x-coordinates. So we'll compare -6 and +2, +3 and -1, and 0 and 0. We want to determine what times these x-coordinates would give us these x-coordinates. We can determine that value, then b is the reciprocal of that value. So it may be helpful to set up an equation in this case. We want to know -6 times what is equal to +2. So -6 times x equals +2, or if we want, 3 times what would be -1. 3 times x equals -1. This equation is easier to solve. Dividing both sides by 3, we have x equals -1/3. Of course, we could solve this equation too and still get -1/3. Again, this is not b. b is the reciprocal of this value, so b would be -3. But if we wanted to, we could set up an equation and set 1 divided by b equal to -1/3, cross multiply and solve for b. So we'd have -b equals +3, or b equals -3. Remember the lesson on reflections. If b is negative, we do have a reflection across the y-axis, which we already noticed. So we have g of x equals f of -3x. So again, a is 1 and b is -3. I hope you found this helpful.